before you ambil subjek retaining wall ni, shear key ni familiarize dah kan? You pernah dengar kan sepatutnya? Pernah dengar ke? Ya ke?
Tak pernah, doktor.
Sepatutnya pernah dengar.
Tu tak dengar. Shear force, shear strength.
No. I mean not in soil punya subjek. You pernah dengar dalam structure? Pernah dengar tak?
Tak, doktor.
Ya.
Tak pernah.
Shear strength ada.
Shear key digunakan juga untuk dalam construction, building construction, kan? And then kalau key tu you pernah dengar lah, key tu yang untuk guna earthwork punya formation, form tu apa semua. But then shear key ni dalam building, especially in dia punya pembinaan beam or slab, they need to put a shear key ni sebab untuk nak retain ataupun nak inilah structures tu against sliding juga. Because we don't talk about retaining wall punya sliding je. And the building atau wall tu sendiri pun, bangunan-bangunan tu pun perlu ada benda tu kan. So that's why I'm not so sure, mungkin you perasan shear key ni bukan saja terletak kat bahagian bawah certain part bawah sekali, but then in the between of parts of structure pun dia ada juga letak. It depends pada keadaan bangunan ataupun structure tu sendiri kan. So before we move on tu kan, nak cakap ni shear key ni is more on sliding purposes lah. Nak enforce the resistance for sliding apa-apa. Tapi yang kat sini saya just nak highlight untuk retaining walls lah. You mungkin boleh cari lepas ni cari details about shear key, the function of shear key, just a very light reading etc. Okay, so talking about retaining walls ni, kalau kan kita ada berapa 3 stability that you need to fulfill. One of it is the sliding punya ni kan. Kalau berlaku slide ataupun gelinciran ni, maka kalau in terms of certain movement or etc. So it will achieve the failure punya stage. So you tak nak lah macam tu, isn't it? So normally untuk sliding problems ni kita highlightkan kat keadaan tapak yang mengandungi ataupun yang existence of the poor soils ni obvious. Poor soil ni macam saya highlight dulu-dululah. I mean in terms of masa soil 1, soil 2, even foundation pun sepatutnya ada highlights what is category of poor soil ni. And you should dig more about it. Then so if you look at the figures here, I share with you for the sliding problems ni, shear key untuk retaining wall normally they put it at the bottom of the base of the structure itself. Tapi some part of it ada juga dia letak at the bottom of the stem. Kat bahagian stem tu pun ada shear key juga dia letak. So that's a different approach untuk mengelakkan berlakunya sliding lah. But of course it depends on how the engineer design it. Engineer nak design macam mana, balik kepada kriteria-kriteria keperluan untuk mereka bentuk wall tu kan. Yang ni just want to refresh you. Kecil ke? Ke besar dia punya slide ni? Sekejap saya ni kan.
Kecil doktor.
Saya besar.
Ni baru besar.
Alright. So pressure acting on the retaining wall. Saya fokus on the retaining wall. So if you look at here, yang ni memang kita sepatutnya well known lah, which is for the surcharge loads. Kalau ada, macam saya kata tadi, if there's a surcharge on top of the backfill ni ataupun retain mass, backfill sebab you tambah tanah yang baru, retain or the original or the natural earth pun boleh juga berlaku if there's a surcharge. Then pressures kat sini also can be considered from the high water level table, groundwater level, Then satu lagi, yang ni yang saya tak nak tekankan sangat, tapi should be a design on it. If you are design di stem ni, bahagian ni, stem ni dia extend above the backfill, maksudnya dia ada terlebih sikit, so you need to consider the wind load punya. Untuk wind load punya exposure. So kena kira juga dia punya pressures on that. Then another yang terkini lah, kita kata recently, if there's kalau kata berlaku earthquake, which is here retaining wall yang you nak design ni, kat location yang berlakunya earthquake, which is there's a seismic zone. Contohnya kat Sabah lah, kalau you nak tiba-tiba dapat projek buat retaining wall kat sana kan. Kat mana dah Sabah yang dia punya point of seismic tu? Did you aware? You baca tak? Kita pernah berlaku gempa bumi.
Tahu kat Sabah je, tak ingat kat mana.
Oh ya ke? Jana mungkin tahu kot.
Jana mungkin tahu kot.
Ranau doktor, Ranau
kan? So mean to say that kalau tiba-tiba ada company or development new development area you want to do, then you've been hired to study ataupun to design. First you need to study the location. Tiba sekali orang kata, alamak kat sini ni selalu berlaku gempa bumi, tapi selalu tu tak adalah kerap. And then dia punya dia punya bacaan tu dalam dia punya unit
Skala Richter.
Yes, skala Richter tu tak adalah tinggi sangat kan. Tapi still, you need to consider if you want to design it for the retaining wall. That's another recently punya consideration lah, right? So once you design tu, I mean to say that you need to know, okay, pressure yang akan menghentam you punya retaining wall tu sekian. And then if it's can force provide a force to your retaining wall, then you need to know which part yang akan memberi kesan yang major or minor or kan kat situ. So kat sini applied loads ni which is ini memang kita should be in your knowledge, which is if backfill, saya highlight 3 ni saja. If it's backfill punya applied load, then it should go triangular lateral pressure. Sebab ni kat sini dia akan jadi 3 segi macam tu kan. Mean to say that it differed or varied by that. And if it's surcharge, then dia akan jadi rectangular. Dia sampai bawah, tapi dia still lagi dia memang memberi loads or beban kepada you punya lateral punya part ni lah, force kepada you punya retaining. Then if it's seismic pressure ni yang baru dimasukkan lah recently, but hopefully tak adalah sampai drastically you akan consider, but who knows kan, tiba-tiba you all kena buat retaining wall kat Ranau sana kan, tak adalah menggelupuk, alamak tak pernah dengar pun macam ni apa semua. No, boleh you ni juga kan. So you ada seismic pressure here, so you need to draw it like this backward triangle. Okay, so semua ni lah, if you consider that, including the water table here, this is we call a passive ke active? Yeah, the green one. Passive or active force?
Active.
Passive, active? You tengok balik kat sini. Backfill dia kat bahagian mana? Passive, active?
Aktif.
Active. So if you consider kan, banyaknya active force yang akan menghentam you punya wall, isn't it? And then this passive yang merah ni, passive force ni, kan, kalau kira the passive force should be higher ada value compared to the active force, baru you punya retaining wall tu stable. And unfortunately, your example yang you dah buat spreadsheet apa semua tu, you punya passive force tak cukup untuk counter active force. Kan? So that's why you need to either besarkan you punya base kan, untuk recalculate again for the passive force, or you need to include the key, shear key here at the bottom. Shear key ni tak sepatutnya macam should be in a certain location. Kan? Macam hari tu Ajin ada tanya saya, isn't it? You show me the figure, cakap kat mana sepatutnya location yang sesuai untuk shear key, isn't it? Ajin ada tanya?
Yes, saya ada tanya doktor.
So you dah dapat jawapan dia? Jahatlah saya ni.
Belum lagi doktor. Sebab saya a bit confusing sebab kalau tengok dari segi shaky dekat sini, dia duduk betul-betul bawah stem. Tapi kalau yang saya punya saya rasa lain sikit saya rasa. Yang saya tengok design dia.
Kat bawah stem. Gambar tu kat hujung heel, isn't it? Ataupun toe. Heel or toe
Dia dekat
kat heel, is it?
Heel lah, yang dekat aktif kan, dekat backfield tu. Dekat bahagian aktif tu, dekat heel. Dan dia tarik sampai reinforcement sampai ke atas.
Dia tarik reinforcement sampai ke atas. Oh, okay, alright. I know why.
Dia punya reinforcement ya.
Okay. So no worries kan. Macam different design should be give a positive punya product ataupun positive punya outcome. Jangan pula question gambar yang dalam buku semua macam kat stamp je kan. So here kat sini kan macam saya kata tadi, shear key ni is additional to the passive force. Sebab you nak counter balik active force kan. So that action should be macam mana nak cakap? Kat sini dia guna ayat counteract. Okay. So it should be designed under the wall of footing. Under the wall. Kat mana dia punya location? It depends. Sebab kat sini dia kata position of the key along the footing is not very important. Tapi engineers prefer to place it just under the stem so that the wall rebars can be extend down into the key. So meaning to say kat sini, even yang Ajin share dengan kita pun kan, dia punya location tu kat heel of the base of your retaining wall, it should be okay. As long as dia punya reinforced still reinforcement punya application tu dia boleh still attach dengan dia punya key tu. Sebab kekuatannya kat situ lah. Kan? Contoh kat sini sebab dia letak bawah sekali ni, sebab dia kata daripada stem ni kan ada reinforce juga. Ada steel tu kan, ada besi tu. Kan you nak buat dinding ke, you nak buat slab or wall kan, you letak reinforcement punya ni kan, steel kan. Steel tu kan, nanti kat sini dia kata untuk stem tu senang, dia bawa turun je ke bawah. Or some other designer ataupun engineer, dia kata tak apa, kita design je daripada bottom ni, letak je reinforcement kat bottom ni, letak je. Boleh tarik ke kiri ataupun ke kanan. So you'll find it is either sama ada kat heel ataupun toe, jangan terkejut nanti. Ataupun kat tengah-tengah tu je sebab senang je nak buat ni. Right. So hopefully it should clear enough. And then I just share with you stability untuk factor of safety for overturning, sliding. Yang ni yang memang kita akan guna lah. So this calculation is based on the US punya guidelines. That's the same. Sebab safety, factor of safety ni should be the same. So 1.5 it should be higher than that for overturning or sliding. Sekarang ni kita cakap pasal sliding, meaning to say sekarang ni dalam you punya spreadsheet, you kena add the key under the calculation of passive force. So ini dia punya international building code lah yang saya copy, which is dia kata kat mana-mana pun boleh letak those key or shear key, as long as dia punya reinforce or rebars tu boleh attach to the whole part of the structure. But then unfortunately in 2018, this is 2015, 2018 dia kata dah tak ada dah this statement. Maksud dia macam tak kira sebab sliding some part of it. Sebenarnya kalau you as an engineer, you memang dah design betul-betul dah dia punya base, dia punya stem, memang calculate memang to overcome the sliding punya, but unless tiba-tiba masa construct tu kan, kira balik alamak ni akan menyebabkan sliding, so okay lah kita tambah ni, ataupun you kena redesign balik lah you punya retaining wall tu. Okay, right. So calculation dia macam saya kata tadi lah, sliding should be under the passive force, the friction or resisting force of it. So sekarang ni dalam you punya spreadsheet, this is the calculation contoh lah, a sliding calculation, which is include also the key, shear key ni, right? Then kat sini kalau you nak tengok boleh lah, tapi in US metric punya unit, you don't have to worry, sama je, cuma perbezaan you need to convert kan, right? Then you just refer back to this calculation or the figure untuk dapatkan idea. So untuk passive force ni dia include sekali dengan shear key kat sini, right? So I think should be okay. Again, the dimension and etc. Kat situ lah you kena play around. That's another play time for you. And maksudnya kat sini, alamak dimension nak letak berapa? Nak sama dengan stem punya dimension ke? Ataupun nak kecil sikit ke? Kedalaman dia macam mana? That's why I ask you to use the spreadsheet. At least you can just set the ni, masukkan item shear key dalam you punya passive force punya calculation. Macam tadi Putri dengan group Putri dengan group Jannah missing, you letak value je. No, you need to go in details. After that barulah you boleh masukkan passive force, which is the shear key tu, baru you boleh nampak dia punya perbezaan dia, right? Ada apa-apa pertanyaan? Yes. Five. All right. Yeah. Macam mana nak zoom sini? Besar sangat kan? Right. Untuk stem tu ke? Ni. You masukkan macam mana dalam you punya spreadsheet? You ambil yang straight line tu ke yang slender punya tu? Yang saya bagi tu straight. Okay. Do you still remember example? Alamak, yang ni memang you kena cari balik dalam you punya nota yang lama-lama. Sloping backfill. Sloping backfill, ups and then sloping retaining wall. Dia ada calculation dia, which is you kena cari you punya tan, sin, apa semua tu. Yes. Kalau yang you don't have to worry. Kalau yang apa ada sloping backfill, maksud dia backfill dia ada slope ke atas ataupun punya retaining wall ni ada sloping for the wall itself or for the stem, dia akan bagi sudut. So you don't have to worry lah macam alamak I have no ideas and etc. Bila dia bagi sudut meaning to say that you need to use your trigonometry punya knowledge. Alright. Yang ni saya boleh kecilkan? Boleh, alright. Okay. Backfill. Yes, yes. Uh-huh. Yes, indeed. Dia akan berbeza. Dia akan berbeza. Sebab bila ada berlaku crack on top of the backfill tu kan. Kat situ you kena consider there's akan berlaku water punya takungan kat atas tu menyebabkan berlakunya force yang lagi besar. So itu dia ada punya equation dia. You don't have to worry. Nanti dig balik nota tu. Indeed. This is conventional sahaja. Moreover kalau yang even sloping tu pun janganlah nak guna spreadsheet ni. This is for the simplest one Macam saya kata tadi kan, untuk retaining wall punya design, you need to start with the conventional, yang simplest one first. Then after that, once you got that masterpiece or master punya document ni, you boleh add up sikit. Kalau kata slender, kalau kata ada slope ni, tambah sikit bahagian soil properties ke, ataupun tambah sikit bahagian wall properties ke, kan? So kat situ nanti akan berlaku perubahan lah dari segi you punya okay tak okay stability tu. So about those condition, actually there's respective equation for those condition. So equation tu yang penting you nak masukkan dalam you punya spreadsheet nanti. Alright? Okay. So yang lain-lain macam mana? Saya rasa shear key ni just again macam saya kata tadi, the dimension against up to you. So you just need to play around kedalaman punya lebar apa semua tu kan, sebab kat situ you akan recalculate the passive force untuk menyesuaikan dia punya resistance against the sliding to achieve the factor of safety or not. So saya rasa dia punya, since you dah ada lebar you dah play around isn't it, dia punya base tu besar ni semua, so you dah ada jawapan dia untuk kat situ, okay stability. Tapi untuk yang shear key ni, you maintain the base punya dimension tu yang sama previous, yang mula-mula tu baru you play around with the shear key punya dimension. Kalau tak nanti you pening, right? That's why I ask you to copy the first one, the original one, then you make a copy one for base dimension, play around with it, then copy two for the shear key, dan include the shear key, then you play around. Right. So untuk yang saya rasa saya kena ni balik lah, yang untuk saya kena delete assignment number 2 tu. You want to submit it individu ke group including yang shear key ni? Nak individu, okay. Kalau individu
Assignment tu doktor, maksud doktor.
Sebab kalau individu you just need to submit it within 4 days tu lah. Kalau kata by group, you kena sit down lagi lah, discuss dengan you punya members and etc. Kalau sit down, saya nak you provide me a proof lah, like a link. So nanti saya delete yang assignment 2 tu, saya buat new assignment, grouping punya submission. How is it? Cik, macam bargain apa entah.
Okay doktor. Boleh.
Tak apa, you bincang dulu lah, nanti you inform dalam minggu ni sebab you ada 4 hari. 4 hari, Jumaat, Sabtu, Ahad, Isnin kena hantar dah. Right, tak apalah, you bincang dulu. Alright. So, last slide. Yes, last slide. Last slide, you don't have to worry, walaupun 30 tapi saya cuba pendekkan sebab ini semua pembacaan. Alright. We want to talk about ground anchor. So hopefully yang ni saya masukkanlah dalam test 1 sikit Cik minta kebenaran. Bolehlah. Ground anchor So ground anchors untuk this topic we divide it into 3 subtopic. First, introduction, design, then construction methods. Actually those are involving the procedures and also the step by step things. So saya tak masukkan equation, so meaning to say that you don't have to worry for your test 1 tu tak ada lah calculation or in terms of design the ground anchors. So just a bit introduction lah, a brief one. Talking about ground anchors ni memang menjadi kesukaan engineers nowadays, especially with if you deal with a condition yang memang kind of have a potential of landslide or there's erosion tak sangat, landslide lah, big major construction, but then of course it's costly, mahal, because they have a few parts that you need to design and a few parts that you need to masuk guna kilang lah untuk ni kan dia punya produk tu. And however, if you compare with the rock bolts or soil nailing, this is more apa orang panggil ni, again reliable lah. If you're talking about the sliding purposes, to reduce the sliding purposes. So ground anchor is the reliable but then costly. Okay. So purpose, it's a very simple one. Purpose, of course, you want to prevent berlakunya erosion ataupun erosion to small movement ataupun yang big movement is a landslide itself. So gambar ni saya ambil daripada website NM. NM ni stand for dia punya invention lah, the ground anchor, tapi dia punya conventional punya method or design is a conventional punya ground anchor. So they implement the ground anchor here in this slope, which is slope ni kalau you tengok macam dah nampak lah macam nak runtuh je kan, macam dah berlaku runtuhan ataupun apa semua kan, but then still because they want to maintain the slope, tak nak lah macam cut and after that buat retaining wall, kena backfill, masukkan infill lain apa semua kan, there's a lot of movement punya ni, transportation and workers and etc. They come up with the design using a ground anchors. But then of course lah, you nak maintain satu bukit tu daripada runtuhan, berlakunya runtuhan, you can imagine how big are their anchors to hold the ground. They call it ground anchors sebabnya they have a few parts of it lah. This is a components which is saya tak akan masukkan dalam test 1 suruh you draw this and then again macam ni, macam yang saya buat retaining wall tu. Sebab nanti saya takut nanti sebiji keluar macam ni juga. Right, sebabnya memang design dia kena macam ni. This is a basic components. You have the anchorage yang highlights warna hijau punya box ni. The anchorage part ni includes the anchor head, bearing plate, and then there's a wall. They call it wall here because it's in front of the ground itself. Then you have the free stressing length. This is the unbonded. They call it unbonded length here. They have those parts that involve in it. Then last one is the length, which is the anchor bond. This is the anchor part lah, which is kat mana dia hold that particular anchor head dengan unbonded length tu tadi. So sebenarnya kan kalau you nak imagine anchor ni, ground anchor ni dia macam paku payung. Pernah tengok paku payung?
Pernah.
Paku apa guna paku payung tu kan, dia ada kepala dia dan ujung dia tu sekali tu of course lah dia tak tengok sepatutnya ada lagi kayu yang akan memegang dos apa yang you paku. Itulah yang saya boleh try to make it you boleh tengok kan, sebab nak pergi kat site this memang memerlukan kebenaran daripada pihak berkuasa juga nak pergi tengok this kind of works right. So a bit definition ataupun just a brief one, what is the anchorage, the ground anchor itself, and then what is the purpose, which is transmit the pre-stressing force from this pre-stressing part, which is here macam paku payung tu lah, you nak make sure that it can hold the certain parts that might be loose, and then you need to make it letak paku kat situ, right? So in terms of designs, kalau you tengok kat sini, if you look at the figures here, so this macam saya tunjuk gambar yang real punya figures tadi kan, there's a part of landslide possibility akan berlaku sini. So dia punya ground anchor tu dia letak at the end of the orang panggil apa kat toe, bahagian kaki bukit ataupun kaki yang landslide tu akan berlaku. Dia akan cut kat situ, which is here you need to, as an engineer, you need to design the anchor, dia punya yang at the end of it ni, yang hold, tie back ni, kat bahagian bedrock. So kat sini again, your punya SI report is most important one lah before you design this, sebab you nak tahu kedalaman bedrock, kedalaman loose soil ataupun kedalaman the type of soil yang poor soil apa semua ni before you design the ground anchor here kat sini. Okay, so this anchor purposely untuk gambar ni untuk landslide stabilization. Alright, so for the design part we have a few steps actually. Kalau you tengok design flowchart ni, it covers all of it, including of course the design of the parts for the anchor itself. So kat sini saya highlights lah a few things that you should know. If you're talking about flowchart, of course one step by step things. Sebab sebelum you suggest the retaining structure ataupun the ground anchor, you need to know is it the criteria is fulfilled or not. Macam contoh kat sini kan untuk check dia punya analysis kestabilan, stability analysis ni, you need to go through all those flow, starting with the selection of the anchor function, then you need to calculate the power of the anchor tu. Sebab ni kat situ lah yang akan menandakan okay your anchor is good enough to hold to prevent the soil from slide. Then if is the anchor suitable, then you can proceed. If not, then you need to initiate arrangement of the anchor again. It just goes back to check the initial arrangement of, because you know arrangement of anchors tu depends on the availability ataupun the existence of the bedrock, tempat yang dia akan memegang. At the same time, you need to design the grouting amount of volume yang you nak masa you nak install the ground anchors tu, masa you nak install paku tu lah, pendek cerita. Alright. So it's not about the anchor itself. You need to know about the length of the anchor, panjang punya ni, and then also the bearing plate of the design. So each of it have the calculation. You don't have to, itu nanti saya akan detailkan. Right. So again, this is yang ni saya rasa you baca je kot boleh ke? You nak saya go through? Alamak dah 4:40. Alright. You baca je boleh? Nak terang sikit, okay, this is some sort like again based on the design procedures tadi. Of course you need to know to make sure, bukan to know, you need to make sure that in terms of the ground anchors to the bearing capacity of the soil of the ground ni you need to know. Sebabnya bila you masukkan anchors tu, it's not that the anchor itself je yang akan bertindak. No. Dia punya ground tu sendiri pun akan bertindak. Meaning to say that there's a friction or effect from the ground itself yang akan mengukuhkan lagi you punya ground anchor tu. Tu pasal dia panggil ground anchor. Kan dia bukan berkaitan dengan anchor tu saja kan. Macam sebenarnya kan macam kalau you nak imagine paku payung tu lah tadi. Kan? Dia punya kekuatan kayu yang akan menahan ataupun yang akan menerima paku tu nanti pun diambil kira juga. Kan? So and then also the bond strength between the anchor, grout and rod. Sebabnya this is anchor grout. Grouting ni simen lah. Kan? Bila you masukkan anchor paku tu pada masa yang sama sekeliling tu yang akan inject the grouting, grout tu. So grout ni pun sebenarnya you akan refer back to the cement punya calculation, the concrete pipe lah. Kat sini you dah belajar subjek material kan, so you kena tahulah campuran tu apa semua kan yang menyebabkan boleh kukuh and then intact dengan dia punya anchor tu sendiri. Okay, so actually for the untuk those ground anchors ni, of course design is one part. You dah design, you dah bukan implement construct, but then at the end of it you need to test. Kena test. You bukan main buat design, construct, buat je, lepas tu tinggal. No, you kena test. So there are two tests, which is there are bond strength test, and then there's a bearing capacity test. The bond strength test ni kalau you nak check dalam Google kan, it is some sort like a pull out test. Dia akan check, okay, kalau dah fix, dah buat ni mungkin dalam seminggu, grouting dah keras, anchor head dah ketat apa semua tu, then you kena check dia punya pull out test. Pull out tu maksudnya dia tarik keluar dan you akan tengok dia punya capacity yang boleh menyebabkan dia loose or not, ataupun dia boleh hold. So kalau dia boleh hold for a certain time and etc, then bagus. And your design success lah. Kalau tiba-tiba you baru je buat and it's loose, keluar ada paku dia tu, it will give you a trouble lah, nanti kena menjawab. Then we have the stability analysis and calculation. There's one big ataupun the basic equation, which is here you want to check the power of the anchors. So for the powers anchors ni, it relate to the factor of safety yang you nak kena refer, of course. Bukan kata design without reference anything, yeah. Then juga sudut-sudut yang tertentu lah for the anchor work, for the anchor ground anchors ni. So here we have, if you notice, we have P1 and we have P2, right? So this P1 and P2 ni, this is the effect, effect yang akan provide the force to the anchors, right? Which is here. If it's clamping, so here clamping effect here, ni kat bawah ni, so it can increase the resisting power against the shear force. But then if it's training effect here, kalau kata yang ni tinggi, yang tu rendah semua kan, it can decrease the sliding force and then it's good. Yeah, so kat sini P1 and P2 ni you nak kena double check lah in order to get the power of the your ground anchor. Again, you just need to play around with this equation and also the angles given. Okay, right. Macam saya cakap ni, this is the power of your anchors, and then this P1 and P2 is the effect for the anchors itself. Alright, so this is some sort like a condition lah, the effect of the anchors, which is which one you should select to make sure that the sliding is in a good ways lah. Alright, right. Then again, yang saya kata tadi kan, step by step thing, the procedure, the arrangement of anchors ni pun the main things that you need to do. Sebab kalau you dah check the anchors, the length and then the bearing plate and etc., then suddenly it doesn't suit with result that you want to design, then you need to go back to the arrangement of the anchors. Okay, so here if you can compare, there's a good layout for figure A and then there's a bad layout for figure B. Okay, so if you look at here, this is a good layout which is at the toe of the ground slope. Kat bahagian bawah sekali, toe, kita panggil kat bahagian hujung kaki dia lah, the toe, right? Toe ibu jari kan? Hello. Tak apalah, saya go through. Okay, so the concrete creek works ini, it should be here at the toe of the slope. And then dia punya ground anchor ni kat bahagian rock back. Senang dia nak, bukan senang, it's to make sure that it can hold the anchor, and then even though there's maybe some mini sliding will be occurred here, but then still the surface is still can boleh hold intact. Compared to the B figure ni, bad layout here, which is if you put it here, I mean to say that if there's a small or mini sliding occurs, there might be swept away your anchors too, walaupun your ground anchor ni still attached to the bedrock. Okay, so this is a comparison and they call it a conceptual layout. So in terms of arrangement ni, you boleh baca lah which based on the degrees of inclination and then some of the spacing part and etc. Okay, then there's in terms of equation used to calculate the design anchor power, you also can use this one. For the for this one is the preventive power. Same, then by including the interval between anchors and also number of anchors based on the arrangement of the anchors also. So then the 6 factors ataupun 6 factors lah for the design part is determination of to determine the type of anchors and steel material, which is the one that the unbounded length tadi lah. You nak kena tahu juga steel jenis apa semua kan. So that part is included in the design procedures. So here I want to share with the in terms of the design and anchorage practice. There are 4 types, which is this is the main types based on Little John 1990. It is either you have the straight shaft gravity grouted ataupun pressure grouted here, or the post grouted, which is if you look at here, the grout tu, cement tu dah masuk ke celah-celah ground itself and under rim punya grouted ground anchors. So this is the main type lah. Each of it, if you want to look at the description, maybe you can just highlight the name and then you can Google it, right? Then the determination is once you type of anchor and steel material. 6, 7, sorry. The fixation line ni. Punya length, fixation line ni pun you kena ambil kira juga. You kena ni, which is it should be 3 to 10 meters. But again, there's a limit of it lah. 3 to 10 meters pun you need to study the bedrock punya existence dulu before you propose any of the length to it. And then is it okay or not to use a higher length sampai 10 meter or 15 meter. It depends on the calculation, right? So you can have a good rig there in order to fulfill the fixation length. Okay, so there's a calculation or equation here. You don't have to worry, not too much lagi sebab saya tak bagi lagi example apa semua. This is a recommend allowable adhesive stress. There's stresses from the adhesive itself before you use to any type of tendon yang you nak guna dalam you punya ground anchors tu. Alright, so this is from manual for slope protection. And then also the skin frictional resistant of anchors. This is such as like a foundation lah, kan? You nak buat piling ataupun those concrete pile or steel pile kan, you kena tahu those resistance of the from the structure itself. And then this is the skin frictional punya ni kan, each for the type of ground, bedrock, sand, and gravel sand, berapa N value dia apa semua. Okay? Right. Then last is the design of bearing plates. The bearing plates is also need to be designed. Or else nanti sia-sia je lah you punya length banyak mana apa semua, then those bearing plates still lagi tak boleh nak cope in dengan you punya design of anchor, ground anchors itself, right? So the design of it, if you look at here, there's also present a conceptual layout for it, which is either for the road application. If you look at here, it's at the upper part for the ni, and then if it's just only for the ground surface or for the landslide potential punya slope tadi, this is also the bearing plate that you need to design. Okay, so this is the bearing plate here. Okay, then the pedestal and then also the parts of it lah yang you kena tahu. Refer back to the first figure yang I share with you before. Okay, last is construction method. The construction method ni saya share about the notice ataupun dia punya description on how to construct. It's just a reading part, so you just need to read it. It's about the percentage and the duration for each of it. Also for the ground anchors punya construction. Okay, done. Right. That is tak sampai pukul 5 lagi. Alright, so any other question about this part, slide? Ingat yang ni masuk dalam test Yes? Which slide, Fazli? Oh, okay, mudah. Mm-hmm. Kalau tengok kat situ kan, sebab tadi saya tunjuk yang type-type dia. Sekejap mana gambar ni. This one. Okay. This one kan. So you kata tadi apa? Stiff clay Okay. So the thing here is about the grouted part. Yang bahagian grouted. Cement tu tadi nak masuk. Okay. The thing is, of course, you need to make sure that grout, cement yang you nak bancuh tu, cement nak bancuh pun ada type jenis-jenis dia juga, isn't it? So you need to make sure that type of grout and then the properties of soil that you need to then you need to know that which part, again, if it's type A, kan masuk straight shaft gravity grouted ni contohnya, so the machinery can occupy or not with that stiff clay. Saya tak boleh cakap nanti stiff clay untuk gravity grouted sahaja, no. Saya tak boleh cakap. Sebabnya, as you know, the type of soil varied, isn't it? Tiba sekali bila you drill, yang ni you kena drill ni. Alah, saya tak adalah video tu. Tak apa, nanti saya cari, saya tengok. You drill dulu, you drill, buat lubang ni, then after that you masukkan you punya ekor paku tu masuk the steel, the unbonded fixation line tu you masuk kat sini, then after that baru you tengok sometimes it's not that, maybe this part is stiff clay. Mungkin kalau kata you buat site investigation, this part or this part ataupun this part kan dia ada banyak-banyak location of borehole punya ni kan. So who knows, tiba sekali stiff clay ni kat sini. Tapi kat sini sand masa mula-mula masuk ataupun gravels a lot. So there might be a complicated decision for you. So if say kalau kata dah tahu kat sini stiff clay, jadi saya nak masuk dalam 10 meter, sini stiff clay. So you should know lah which one that applicable machineries, you punya grout punya bancuhan tu, and then you punya steel materials yang you nak guna kan. So macam saya kata tadi, if you want to know in details, you maybe highlight this type A straight shaft gravity grouted ni, mana apa dia yang you boleh kriteria. Boleh, you boleh decide. Let's say kan, saya tak nak cakap straight shaft gravity grouted ni untuk stiff plate. No, tak boleh macam tu. Dia lebih kepada macam how it works ataupun macam mana dia punya ialah how it works lah. And moreover is macam mana you nak apply benda tu. Benda tu adalah ground anchor kita ni lah. Paku kita. Yes. It's not about you tahu je kriteria tanah tu, okay saya tahulah saya guna paku ni sekian dan saya nak guna type A punya ni. Mungkin if it's possible, but who knows, mungkin kat bawah satu kawasan saja you boleh guna kan. Satu kawasan lagi alamak kena type B pula. And satu kawasan lagi alamak type C kan. So it's not that apa panggil ni? Lump sum punya decision lah. Sebab saya pernah experience kat satu tapak tu, dia punya daripada front wall ni, bahagian front ni, depan sampai ke dia dah drill. Masa ni this is drilling process, memang batu besar-besar. So it's a bit complicated lah untuk engineer to decide kita nak guna grouted, post grouted or under rim or whatever. And sebab sometimes tengok kat tengah-tengah ni pun dah ada macam lompang-lompang apa semua. So tak apa, you boleh tengok ni, you boleh mungkin you can refer to this reference ni, ground anchorage practice. Then look in details about it. Okay. It depends on there's a certain criteria lah, which is if you go through to the design procedures tu tadi. Alright? Okay. Sebab design procedures tu kan ada 3 main parts. Mana tadi? Yeah. So 3 main parts that you need to consider. The first one is the arrangement of anchors. Yeah? Then the second one is the type of anchor and steel material. And then the fixation length, which is the panjang paku tu. And then last is the bearing plate. So this parts that you need to consider before you choose the type of grouting tu. Yang tadi grouting punya part, it's not the anchor. Don't misunderstood. Yang ni this is grouting. Grouted. Cara nak menyimen. Boleh aku guna perkataan tu? Grouted. Grout. Cement. Cemented punya ni. Alright. So ada apa-apa persoalan lagi?
Oh, doktor, saya nak tanya.
Ya. Yeah.
Anchor ni dia sama ke macam soil nailing? Macam perasaan saya sama. Saya tak tahulah perasaan saya.
Perasaan sama? Sama ke tak? Tadi saya ada explain.
Macam sama.
Cari. Nanti share. Kalau saya cakap sama tak sama kan nanti terus jadi macam okeylah malaslah nak dig more. Tak boleh. Cari. Sama ke tak soil nailing dengan anchor ground anchors? Boleh? Alright. So untuk hari ni punya task adalah just share with me ataupun submit link tadi, group discussion. Dan alamak, bateri habis. Okay, saya ada masa 15 minit. Okay, Jangan lupa tick your attendance. Okay. Then untuk test 1 masuk sampai bukan hari ni yang masuk sampai hari ni punya nota daripada awal lah. Tapi saya tak katalah masuk nota tu kan, sebabnya you all bukan tak percaya. Tapi tiba-tiba rasa macam nak tengok balik kan. No lah. Then saya rasa test 1 tu saya better buat saya give you share with the example dulu. Lepas tu saya tinggalkan you all buat test lah. Boleh ke? Sebabnya saya rasa macam mungkin you all nak minta extend masa. So kalau you nak extend masa,
Doktor test 1 open book
sekejap,
atau close book?
saya charge dulu.
Sejuk.
Okay. Apa tadi? Jannah Test 1. Apa?
Untuk test 1 open book atau close book?
Saya tak nak cakap close book. Dia dah bukan jadi open book, dia jadi open source. So no worries, saya akan bagi soalan yang memang you all akan sebenarnya you kind of familiarize lah dengan benda ni. So you don't have to worry lah. Saya cuma cakap extend masa tu sebab bukan nak kata soalan tu susah ke apa, tak, tapi it is some sort like habit kan. Rasa tak cukup masa 15 minit kan. So that's why saya rasa better saya guna dulu 1 jam untuk next week punya kelas. Then 2 jam tu saya bagi you all play around lah dengan you punya test. Okay. So kalau minta extend ke apa semua, saya extend dia punya period tu sampai pukul 6. Tapi itulah penat kan duduk depan sampai pukul 6. Tapi hey, design lah. We talking about design, data structure. No. Kalau teori, sebiji keluar you copy paste. No. I don't trust you. Design. Kalau kata masuk yang hari ni teori lah kan. Tapi tak adalah sebiji macam tu. Saya olah lah sikit soalan dia. So normally untuk test 1, saya punya practice adalah dalam 2 atau 3 soalan je. Sikit je. The most lah tu 3 soalan. Paling kurang 2 soalan. You don't have to worry lah. You dah buat benda ni. Saya tak bagi soalan yang ni. InsyaAllah. Ada apa-apa persoalan lagi? Boleh ya, saya buat 1 jam awal untuk lecture lah. Which is not that lecture. Saya nak share punya examples untuk ground anchors ni. Design apa semua tu lah. Yeah. You don't have to worry lah, tak masuk dalam tu. Sebab tak belajar lagi kan. Alright. So if you notice dalam your Putra Blast, alamak, sekejap saya share. If you notice saya ada share work example retaining wall. Untuk dalam field compaction and retaining wall tu saya ada share work example. If you can have a view, boleh tengok dia punya work example tu, yang tu saya ambil daripada internet directly. Saya share juga saya share punya link lah tu. You just click the link and you tengok punya stability punya calculation, right? And the most yang additional part tu dia masukkan structural punya calculation. Sebelum ni kita just kaji pula, kita just calculate the stability which is those overturning, sliding and bearing pressure kan. Yang ni untuk work example ni dia masukkan the structural part which is pengiraan untuk steel punya reinforcement and etc. It relates to your structural analysis subject. So hopefully this is ni lah kan. Saya tak kata yang ni masuk saya just suruh tengok saja. Okay then. Sorry? Test 1? 30. 15. 15. Test 2 15. And final exam 40%. Okay. Right. Ada apa-apa persoalan lagi? Tak ada? So, yes. Yes. Untuk next session. Okay. So for today's session, submit link group discussion. So you all agree ke tak ni saya nak delete assignment tu? By group or individual? If it's individual, I will stay like that lah. Better sekarang kot sebab esok lusa you nak fokus IDP lah. Next week nak lepas IDP lah. Well, lepas IDP hari Rabu je lah kan. You nak study dahulu. Nak study. Huh? Term break? Discussion untuk apa ni? Alright. So you nak prolong lagi lah ni? Untuk assignment you, assignment number 2, which is
Minggu depan, okay kot doktor. Minggu depan okay. Lepas editing.
Sampai individu lah ni? Individu.
Kalau grouping kena buat video doktor? Kena ada video discussion kalau grouping.
Kalau grouping, submit grouping, tapi you kena discuss tadilah, yang tadi link tadi kan. Tapi in details lagi lah sebab tadi you discuss, you baru jumpa hiccups kat situ, hiccups kat sini apa semua kan.
So, maksudnya perlu hantar video lah kalau, hantar link lah
link.
Kalau apa nama grouping.
Link and assignment lah.
Yelah link and assignment.
Group kot pada saya lah.
Macam ni lah. Saya delete assignment tu. Then you polish your master document in group. Then you submit after term break. Boleh? So you got extra 1 week lah untuk discuss and polish and blah blah blah. Yeah?
Okay.
Boleh.
Itu
So,
termasuk share key tu lah kan doktor?
Sorry?
Yang
Share key. Masuk share key. And then perbezaan lebar apa semua tu. Those two worksheet. This is just for simple lah. Alright. Saya tak nak masukkan lah structural tu ke saya nak masukkan ni? You tengok dulu assignment tu. You tengok dulu work example tu. Saya rasa just a small part for structural analysis for the retaining wall. So okay, for the time being, Fazli suka buat summary. Fazli summarize. Summarize lah. Apa ni? Yes. Number two. Yeah. Yelah, assignment 1 dah hantar kan? Yes. 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 Yeah, betul. Assignment and the link for the group discussion. Yes. Indeed. Okay, done. Hope everyone clears, Okay. Saya sebenarnya saya tak nak bebankan with too much assignments and etc. Tapi saya rasa macam this is keperluan. Kalau saya tak ajar sekarang, you dah tak belajar dah. Unless masa you kerja, you still contact me. Itu tak apalah. Boleh, feel free to. Okay? Alright then, so Alhamdulillah, I think we can end our session. Just focus for whatever we discussed today. For preparing the test one, okay? So, I think I'll see you. I'm not so sure. Your IDP maybe in a big seminar or whatever because Dr. Farah pun tak share apa-apa lagi dengan saya. But then hopefully I can see you, all of you, on Tuesday lah, right? About your with your IDP presentation. Good luck.
Okay, thank you.
Okay then. So Assalamualaikum.
Thank you,
Salam.
Doctor.
Thank you, Doctor.
Bye.
Thank you,
Thank you,
Doctor.
Doctor. Bye.
Okay, Doktor.